go back quickly so that I can show the front screen. And then, yeah, here we go. Short and sweet, to the point. Feels really good. Be quiet! I just like doing that. I love scaring middle schoolers. My favorite. You guys were scared of me last.
I didn't know that we were last year. Oh.
What did you say? It's okay. That's how the people view me.
You just made much. I wanted to know in the high school teachers, I just didn't know.
Okay. You should be seeing some common words up here that you've probably heard or seen before. Notice what is in the definition of thermal energy that we just talked about. What's in the definition of thermal energy that we just talked about? Kinetic energy. So thermal energy is a specific kind of kinetic energy. What did I say kinetic energy was? Okay, energy in motion, or the energy that causes an object to move, or while it's moving, the energy that it has. Okay? So thermal energy is the sum of the kinetic energies of all the particles. Okay, this gas has a bunch of particles that make it up. It doesn't appear to be moving. So does that mean it has no thermal energy? Okay, the question is, it's not is it moving, yes or no? The question you should ask is, can I see it moving, yes or no? Why do I say it that way? Everything's moving. You guys know that it's not possible to get an object or something to completely stop moving. Joe, no. We haven't been able to do it. Okay, there's a term called absolute zero, which is in theory the coldest temperature that could ever theoretically be achieved. And I don't know if you guys know this, but let's look at the definition of temperature. Oh, it's not up here, is it? Okay, so the definition of temperature is the average kinetic energy. If your temperature is your lowest, that means you have no kinetic energy, which would mean you would cease to move. That would be when, in theory, things stop what? Moving altogether. That's, according to what we have been able to figure out, is impossible. I don't know if that creates a black hole or they just blow up. I don't know. Just As of right now, we've gotten it to like 0.0000001 degree. We've never got it to 0. Now I'm talking about the Kelvin scale. You're probably going, oh, I see negatives degree Fahrenheit all the time. I haven't shown you the Kelvin scale, have I? Okay, we'll talk about that later. All right. But so you're probably thinking, that desk doesn't appear to be moving. Does that mean it has no kinetic energy? Okay, so what's probably true then? Yeah, it's moving when we can't see it. Okay? All solid particles are moving. All liquid particles are moving. All gaseous particles are moving. Solid particles are vibrating, going like this. Now we can't see it because they're so small, but all solid particles are vibrating like this. Yeah, look closely, you might be able to see it. No, you won't be able to see it because they're so small. Okay? But they're all moving. Okay? Now, what do we usually say has more energy, solids or gases? Gases, right? Gases are moving faster than solids, that's why they have more thermal energy. Okay? When you change your thermal energy, okay, so what I mean by this is a lot of people use the word heat wrong. They say this has a lot of heat or something like crazy like that. Well, heat only happens when you have different temperatures and energies transfer from hot to cold. Heat is energy transferred, heat energy transferred, or thermal energy being transferred. Okay? So when you open up your door in the winter, hot air from inside goes outside. Did you guys ever know? Did you ever think that cold air came in?
Yes.
Nope. Cold air does not come in. Hot air goes out. Did you know that? What? It doesn't get in. Hot air goes out and then it feels colder. Because you're losing energy from inside to outside. Cold air does not come in. Not possible. Yep. Energy's always transferred from hot to cold, never the other way around. Now, you can do work to go from hot to cold, or from cold to, no, yeah. Yeah, that's what refrigerators do. Okay, but you have to put in energy to do that to work, which that's like college level. Okay, all right. So thermal energy is the moving energy of your particles. Okay, when the thermal energy moves, it's called heat. So for example, if you take a hot cup of coffee, put your hand on it. It feels warm, doesn't it? That's because the hot cup of coffee is touching the cup, and the cup is transferring thermal energy to your hand. That's called heat. Okay. All right. So, you're probably familiar with temperature, correct? Okay. We know that thermal energy's been transferred, or we know that heat is going, heat transfer is happening when you see a what? Temperature change. Okay? So if you see the temperature going up, that means thermal energy is being transferred to the system, making it warmer, and that's why you see a temperature change. Okay? Now, I'm not going to say too much about this. It should make sense. Gaining thermal energy, you are what? That's common sense, right? Common sense tells us that. Losing thermal energy means we are cooling. Next. Whoopsies, wrong way. Ooh, acoustic. What kind of energy do you think that is? Sound. Whoops. Time to go. Okay, get this in. You may leave and we'll finish it tomorrow. Here's a hiding the hole in my butt. I mean, the hole in my